Welcome to another episode of the .NET Show. Now in this episode we're going to talk about ORM, Object Role Modeling. Object Role Modeling is a way of dealing with databases and figuring out how to take and document your database, organize your database, as well as structure your database so it actually solves the problems that you're trying to get it to solve. And as we're learning today's episode, it also helps us debug databases that we might have actually thought at one time were working perfectly fine. But before we get to that, let's check in with Erica and the news.
Hello, I'm Erica Wiechers. Welcome to the MSDN News Update. In late April, MSDN launched a new community site designed to be a launching pad for communicating online with other developers about Microsoft products, technologies, and services. The site includes quick access to newsgroups, chats, how-tos, third-party community sites, user groups, and more. Check out the new site at msdn.microsoft.com/community. In May, Microsoft released the first beta of the Microsoft SOAP Toolkit version 3.0. The major features in this release are a generic type mapper, support for WSDL and XML schema import and include elements, source for the SOAP messaging object framework classes, WSDL wizard enhancements, and many more. You can download the new toolkit from MSDN Downloads. VS Live will be held this year in New York City June 16th through 19th, as well as in Orlando, Florida September 14th through 19th. The conference will feature pre- and post-conference workshops and detailed sessions on technologies such as the .NET Framework, Visual Basic .NET, and ASP.NET, all presented by various industry-known speakers. Early bird registration is still available for the Orlando conference. The .NET Developer Training Tour is back and will take place May 20th through July 1st in various U.S. cities. This intense two-day developer seminar includes 16 training modules that provide a thorough step-by-step overview of Visual Studio .NET, the .NET Framework, and the Microsoft .NET development environment. The sessions are led by Microsoft CTEC instructors selected for their expertise in developer training. Be sure to check out the show transcript for links to more information on these news items. This has been the MSDN News Update. I'm Erica Wiechers.
Welcome back. Now, like I mentioned, we're going to talk today about ORM. Now, ORM is a database technology thing. Now, quite often, programmers aren't always thinking about the databases that they're trying to interact with from a programmatic fashion. So I thought it would be very useful to help you understand what some of the database technology and modeling techniques are about there, specifically focusing on this it's not, I guess, a new model, but this model called ORM. And joining us to talk about ORM is Terry Halpin, a program manager at Microsoft, and Pat Hallock, a partner in Concept, and Dick Barden, also another partner in Concept.
Yes.
Thanks for joining us.
Yeah.
So, Terry, what exactly is ORM? What's like the elevator pitch?
Okay. ORM is short for Object Role Modeling, which is a conceptual way of modeling your data. And it's called that because you view the world simply as made up of objects that play roles. And roles are just parts and relationships. So when you model the data of the world, you just express everything naturally in sentences. And the objects and relationships are just the way you do it.
So it's just an easier way of describing the database and managing the connections between objects and describing the relationships and dependencies. And so rather than dealing with tables and joins and stuff like that, you're using ORM instead?
Yeah, you simply model the world the way you see it, so you don't have to worry about how you group facts into structures like tables. You just say, here are the facts, and you just express them as sentences. And the tool can automatically pick up those sentences and decide how to group them into fully normalized tables for you.
So, like, myself, I'm not really a database person, but every once in a while I've got to bring up, Access or SQL Server to do some stuff, and I kind of have to think roughly in my head, okay, what data am I actually trying to deal with, and can I do it all in one table? I sure hope so, because I really like working with one table at a time. But if I need to do multiple tables, okay, so I got to do that, and then I've got to do some other stuff. So with ORM, I don't quite have to think in that same fashion.
You don't have to worry about that at all. It's actually also called fact-oriented modeling. because you just say, here are the facts I'm interested in. And at the ORM level, how you group facts into structures is not a conceptual issue. So we don't even make a distinction that this fact should be wrapped up as an attribute inside a class or a table. That's a lower level. So if you like, ORM sits on top of other approaches like entity relationship modelling and UML and relational modelling, where you actually have decided this is going to be an attribute in a container.
So it'd be kind of similar, let's say, think about a database and using, Access, where you're drawing the tables and connected between that. Would that be more like, macro programming for the programmer, and ORM would be more like using Pascal or C or Visual Basic or something like that?
Yeah, that's not a bad analogy. It's a truly higher level. Yeah.
Mm-hmm. Now, how long has ORM been around?
ORM's actually been around since about 1974.
That's quite a while.
Yeah, it is.
Now, is it? I mean, I've never heard of it before they're doing this episode like this. But so is it something that people know about quite a bit? Like my audience probably has heard of before.
Well, some of them would have, but many of them wouldn't. I think it's only now that we've got this Microsoft tool that really gives you a powerful support for ORM that a lot of people are going to get really excited about it.
So prior to this, how would they have actually done stuff in ORM?
Well, there have been some earlier tools in ORM that they could use. In fact, some of the best tools have ultimately have evolved into the current tool because Microsoft actually bought companies that made some of these other tools. Mm-hmm. But you can also use ORM without a tool because it's a great way of just thinking about data independent of what you do with it.
And we all like thinking about data.
Yeah, I hope so.
Now, Pat and Dick, I guess you've actually had some experience in working with ORM and comparing it to other processes of dealing with databases and stuff like that.
Yeah, for a long time. I'm one of the early people, about 1980. Spent time not even knowing that there was another way to do it. This was actually the first way that I was ever taught to go about dealing with data. And so when I learned about the other techniques, I was kind of surprised.
How could anybody use a tool so archaic as that? I mean, ORM's around. I mean, doesn't everybody use ORM?
Yeah, we followed it through the years. Back when there were no tools at all, we did it on paper, and we followed it through its history right up until now. And we are formed on the basis, the company itself is formed on the basis of this is what we do, this is what we consult in, this is what we train in, and this is what we like to do with customers. Mm-hmm.
So now, can you specify any specifics on the benefits of ORM over other approaches and practical models?
Yeah, we find it's a lot faster because we don't have to think about the structures that Terry was talking about. And we can also speak in the language of the person that we're talking to. They have a way of naming all their objects already, and they have a way of knowing that how they go together and how they work and what the rules are. And we think one way of thinking about ORM is to think of it as a bit of a specification, because you're not saying, well, I'm going to implement it in this particular manner. In fact, sometimes we do ORM and never implement it. It's used to do vendor analysis would be an example. We're looking for a product that matches what we've just written down. And so we can gather this English and this stuff together quite fast. And to a high degree of accuracy, which is the other part about it. It's easier to get it right and not so much rework.
For instance, one of the projects that we've just used it on is with a law firm. And they've been unhappy with their current debt collection software. And so we interviewed the partners with the law firm. They told us about how their debt collection system works. We took all of those facts, categorized them, and made that into a model, okay? And we used that as the basis for interviewing vendors who supply debt collection software. And in that way, we can come up with a very concise list of gaps and then use that as a means to leverage and negotiate with the vendor for enhancements and such.
So you didn't actually even then provide the actual database they used. You were just basically creating a template that you then held up to each vendor and said, okay, how close do you get to this? How close do you get to this? And as soon as you found a close enough match, you're able to take and say, okay, we'll use you, but make sure you add these fixes to your
That's
your product
exactly
as well.
right. And we can get down to a very, very fine level of detail with the vendor.
Now, in that case, was it you were the only people talking to the vendor, or was the law firm coming in and interviewing as well?
What they would do is they would rely on us to interview the vendor. Then at some point we would bring in the vendor for demoing purposes, and then of course let our clients interact with the vendor also in a great deal. A lot of times they leave a lot of the details to us because there is such an extreme number of details to go over, because they don't have the time, or sometimes the detail orientation to do the interviewing themselves. So, that's the kinds of things that we're hired to do and bring in and actually perform.
But you yourself didn't have to. You really understand the lawyer's business. You didn't have to understand
actually,
debt collection. Or
that's one of the interesting things about ORM, is that as you use it to understand the subject area, you become an expert in the subject area too, because you have to. In order to understand that subject area and actually to do the analysis, you become very well acquainted with the data that actually makes up that system. So now we can, by understanding that, we can hold a much more intelligent discussion with any prospective vendors. And,
one of the things about ORM is that it makes it easy to communicate with non-technical people. So you can just speak in sentences, and there's no restriction on how you can express those sentences. And it's also very rich, as Dick was pointing out. You can get down to fine level of detail, so we can express lots of business rules that the other notations can't, and really drill down.
And currently, ORM right now is tied into Visio. Is that right?
Yeah, it's in the Visio for Enterprise Architects tool, which currently is part of the Visual Studio.NET Enterprise Architect product.
Mm-hmm. So that anybody that's got Visual Studio for Architects would have access to the ORM built into that automatically?
Yeah, that's right.
Okay. Now, prior to VS.NET being available, how would people do ORM development?
Well, we had a partial ORM solution in Visio Enterprise before, but it was quite incomplete. And that actually came from an earlier tool that we had called InfoModeler, which was a reasonably complete solution. It's only just now with the new product out that we've finally gone back and we've given you the full functionality of InfoModeler, and then we've put in extra features as well.
Now, InfoModeler was specifically written for doing ORM data modeling with?
Yeah.
Okay. Now, since Visio is not a database modeling tool, it's kind of a free-form drawing package. I can take and use it for drawing the floor plans of my house. I can use it for doing flow charts and stuff like that. Did you have difficulties in mapping ORM's functionality to Visio as a tool?
Yeah, it was a lot of work to recode the InfoModeler technology on top of the Visio engine. Because Visio is kind of general purpose drawing, as you say, people can do anything with a diagram. They can annotate it, they can colour it, they can move a line here that's kind of unrestricted. So we had to worry about all these events that you don't normally worry about in building a modelling tool, and make sure everything works fine. But in the long run, it's worked out for the best, because now the customers have got a modelling tool that if they want to, they can annotate and put whatever adornments they like on the model. And we simply ignore that at mapping time, but it's great for documentation purposes for them. And we also, because Visio lets you duplicate things unrestrictedly, we had to build into the modelling tool itself the ability to grab a fact type on and just put it on another page. And that was a lot of work, but it's turned out to be extremely useful for the modeler to be able to do that, because they can just grab part of the model and put it on a page and say, show me what you're doing in the universe, and we can just look at it there. So that you'll see this in some of the demos later. It's quite a powerful feature.
So, I mean, it sounds like the InfoModeler tool you had was a great tool for dealing with ORM stuff, but by having to deal with some of the strange issues that came up by going to Visio, you've actually created a tool now that is even more robust and gives the user that much more flexibility in dealing with the data. They can now deal with the data like an organic object almost. They can deal with it from a language level, from a structural level, from a graphical level. They can, grab points and saying, oh, I don't want that logic point coming here. I want this, to be attached to this table as a data point instead.
Yes.
Yeah, in fact, some of the nicer features that we got when this came around was we got the ability to keep the facts separate from the diagrammer. In the older version of the tool, if you deleted something off the diagram, it was gone. And now we have a separation between what the fact model really is and what you can present, which means that we can sort of create a dynamic review. Someone can say, I have a question about customers, for example, and you can put some fact about customer on a page, just a blank page, and say, show me everything that's related to this. And then you can sit down and you can review everything that you've ever said where customer is part of the fact. And we couldn't do that before. We had to create these pages, and we couldn't duplicate certain things. And now we can put a fact on the diagram more than once without harm, whereas before getting the same fact on there was considered a no-no. But this separation between the fact model and the diagrammer has really been a good advantage for us. And again, it helps us very quickly talk to the customer, because we can just find any place in the model we care to talk about and get that diagram up by just saying, show me what's related to what I'm talking about. And that helps quite a bit.
One of the things that you had mentioned before about tying data into points, various points within the model. One of the other things that we do is do add-ons to existing commercial off-the-shelf systems, and we integrate that in with that commercial off-the-shelf system. One of the projects we're involved with right now is St. Paul Public Schools. And they have an area that we're working on called Area Learning Centers. So, in other words, kids go to a high school, and it's usually a very structured day. Okay. Well, occasionally you get, some kids that need to be away from school. In other words, they have other responsibilities, or they've dropped out of school, or they need to work during the day because of family situations and such. And so they need to have a very dynamic school schedule. And so we're doing a model for that, and we're following that model all the way into implementation. And we're actually using the .NET framework, the .NET tools, VB.NET, ASP.NET, and ADO.NET to actually implement that. And Pat can talk more about that.
Yeah, so how exactly does .NET flow into this? I mean, so if we just talk about databases and stuff like that, and it could be SQL Server Access or Oracle or something like that, but using .NET on this, that kind of starts getting some powerful stuff going on.
That's exactly what we've done, is we've used the .NET tool to create the database. We've also used it to figure out how to integrate into the district. And since we have to get the data out of their old systems, we put all this in SQL Server, and then we're using DTS to move the data around. The other database is in SQL Server as well, the main one from the district, and so we're very easily able to communicate with that.
And then there was a legacy database that was in Access.
Yeah, and we have to move the data out, and we'll use DTS to do that. We're going to use Office products, actually, as one of the front ends to replace a lot of the reporting requirements that people usually encounter. These people are very familiar with Excel, as an example. And so we will use a lot of Excel onto web pages so that they can look at things and get information. And the whole thing's being built in Visual Studio.NET, and we happen to be using an ASP type of project because they wanted it to be that way. But the whole thing is being done here, and we're able to see all of our various models, and we're able to use the same tool set to create and modify the database as we see fit. And so we're actually doing the entire product within the .NET world.
Yeah. Another use that we've used it on quite extensively is some very, very large models. On the order of, let's talk tables for a second, 450 tables to 500 tables. And so what we typically do is break that down into major subject areas, have each person work on each subject area, and then merge them together and bring them together to form the larger data model. For instance, like MarketWise, with one of the Czech manufacturing companies in Twin Cities. They needed to have a very comprehensive database where they could profile people, depending on what their credit risks are and all that stuff. So you can use it for some very, very large solutions.
Which was greatly improved. That's another improvement that we got was the ability to have a number of small ORM models that can be brought together for one database logical model, and we can share the objects between. Otherwise, if I'm working on a model that Dick has already worked on and he's already created the objects over on his side, I just merely borrow them. I just say I want to use it. And when I bring them together, it gets its definition from his model, not from my model. And so we can have a number of people working on this in different areas, but we can, meanwhile, share these common points and know where they are. And that, again, is beneficial because we can build these models for different purposes. We can isolate a subject area that we know we might want to use in another database, for example. So we want to use it. We want to use this component here, and we want to turn around and use it over there at some later date.
Another use that we've really found very interesting is hierarchy management. And of course, this has a lot to do with data warehouse and forming dimensions in a data warehouse situation. Hierarchies are always, very complicated, and some of them can be extremely complicated. And so we've been able to find solutions and use ORM in a way that we can create some very robust solutions for hierarchy management. Pat has a lot of experience with hierarchy management in various situations.
The thing in that particular task that it allowed me to do was I could look at the detail, but then I could think about some abstraction of the detail. I wanted to rise it up to a higher level, but I could get all the detail of the lower level. And then I had a technique, a way of saying, well, I want to model this slightly different. Not thinking about the physical database, mind you. I just want to think about the problem itself, and create a model of the model, if you will. And I don't want to worry about, well, what does this mean when I want to put it to a computer? It becomes a good thinking tool.
Yeah, in fact, it really is a great way to think critically, and to actually have a verifiable and repeatable way of actually going about the task of understanding a subject area. I think that's probably one of the strongest things, the most exciting things about ORM is that it is something that you can use, and the methodology that you can be applied over and over again to solve really any problem. So, and to understand that problem, and come to understand it.
In kind of big terms, talking about big database projects. I suppose you could use it for something like the U.S. Census could probably use ORM for modeling any sort of issues you got there. What about small projects? What about I'm at home and I want to manage a recipe database or something like that? Does ORM scale down at that level? Is it really too big of a tool for something like that?
No, it's great for small size applications too. It just makes data modeling just so easy. You just model it the way you think of it. And let the tool go and put that into structures at a lower level for you.
And in fact, when we teach ORM, we'll quite often say, like, rip a page out of the newspaper, like maybe the movie ads, right? And we'll say, okay, let's analyze what movies are, And so let's just take all the examples of all the movie ads on this paper and this page, and make a data model out of it, right? And so that's a very simple little
the movie was directed by some person. Someone acts in the movie. Someone did the artwork. You can sit down and just start talking about what you see and just write it down.
Yeah, as you see when we get to the demos, it makes it easy to know whether you're modeling the thing correctly, because there's only one data structure in ORM, and that's the sentence type, okay? And as you'll see, we use a role notation, and each role corresponds to a column in a factor instance table. So whatever you're talking about, you can populate with instances. So you can always think in terms of concrete examples. And ORM's not just a notation, it's a procedure, so that there's a methodology behind it, which often starts with, give me any examples of the kind of data that your system has to deal with. And you just say it in English. And what you're expressing is facts. And ORM is just, if you like, there's a set of facts. And then there are some constraints you can put on what's allowed as populations of sets of facts. And the graphic notation itself is so rich in terms of the constraints that you can put on compared with other methodologies. You just naturally think of these rules, you put them in, and you validate the rules with the client by just saying that the tool actually will verbalise the rules in English for you, or Japanese, or French, or German, depending on what language you're using. And you back up this verbalisation of the rules in natural language with the populations that illustrate that. I mean, it's almost hard to get it wrong. Yeah. So with ORM, compared with other techniques where I see they iterate through to get their model right, they go through it about 6 times. And at the end, maybe they still haven't quite got it right. With ORM, you just get it right the first time. Well, it makes it easier to get it right the first time. No method's perfect. I mean, you can always be an idiot in applying it, right?
This use of examples that Terry's speaking of is actually one of the ways to get the rules to work for you. If you give it an example set of information or data for a particular fact, you can ask the tool to tell me what rule would I have to put in place in order to make sure that this is how my fact is going to work, controlling the behavior of the fact. So now if you can give me a set of reasonable real-world examples, all we have to do is say, well, analyze that for me, and it'll go ahead and set the rule. And it's good incentive. Those are good incentive to do the examples, but the examples are also a later proof, because sooner or later you forget why did we come up with this rule. And if you go back to the examples are all there in English. It actually creates the fact sentence, inserting the examples into the sentence. You can now remember, well, what did we say on the day that we decided that this is how this ought to work? Because we can read it back as the examples that we consider to be true. We may have a new reviewer in the room and he may disagree, and we can change the examples and change the rules. But we can base it on something tangible rather than just a guess.
So what are some of the other data modeling approaches that compete with ORM, that other people might be using instead of ORM?
Okay, if ORM is general purpose data modeling, so it could be used for anything, not just database applications. In fact, some of our consultants have taken ORM models and mapped them to C# code and so forth. But currently the tool automates the generation of DDL code for databases. It doesn't automate the generation of classes for you. You have to write that yourself. But so if we're looking at database modeling, then it's clearly entity relationship modeling is the dominant competitor in the marketplace for that. The tool actually lets you do ER modeling as well. It's just if we've got this high level we call the conceptual level where you do ORM, push a button, and now we generate down at this lower level, which if you like is entity relationship modeling or relational modeling, and then push another button and generate the physical DDL from it. So for database design, clearly ER modeling, or even just plain table design, a lot of people just go straight to the tables. And when they think of an entity type, they're really just thinking of a table. That's just the reality out there. In software modeling, or say object-oriented code design, UML would be one of the more popular notations at the moment. And actually the tool, we do have a UML solution in our tool as well, but we don't use it for database design. We only use it for object-oriented code design. So we can forward engineer to C#, reverse engineer from C# to a class diagram in UML. But they're the main other methodologies out there.
Mm-hmm. Well, thank you. I mean, before we close down this segment, were there any final words of wisdom you think you want to leave the audience with about some of the architecture regarding ORM and how they can best use it within their own application structures?
One of the things you'll notice when you get to see the notation of ORM is that it's totally extensible and orthogonal in the way it was designed. So that we talk about things like mandatory constraints and uniqueness, and ORM lets you model things the way you think of it. So you might just naturally think about something in terms of an entity relationship. Okay, these constraints are going to work at that level too. If you look at the other notations around there, they tend to not scale properly for entity relationships. Like multiplicity in UML breaks down in many cases. This just gives you a completely flexible way so that you don't have to put on some kind of binary straitjacket. Say, I got to model in binary only. You can model it the way you see it. It's rock solid. I mean, I did my PhD many years ago kind of formalising this. It's essentially first order logic with an enormous amount of sugar on top. It's just a really solid, reliable, highly expressive methodology.
Probably the best advantage when we're consulting is we're speaking their language when we do it. We're able to communicate with them. They don't need to learn a technical language or what all these little annotations that get put onto lines and things inside of boxes, and they don't need to learn what we learn at logical modeling levels. We can speak here now at a much closer to their language, and they can actually give it to us, and we can echo it back. And we find that that's really a much better communication than that's one of the reasons why it gets done faster and more accurately. And they can verify it much more easily.
Yeah, one aspect of that is that you don't have to show a diagram at all to the domain expert.
Right.
You can just give them the verbalization. The tool automatically verbalizes the whole model in natural language. So if they can just look at the English and examples and say, yeah, that's right, that's what I want.
Yeah, and the examples are really the core. It's the data. And so often we run into our colleagues who don't go to the data to find out what the truth is. You've got to go to the data to really be able to figure it out. And that actually is the core to object role modeling. Is everything is predicated on proving what you're saying with data examples. Yeah, so that's very, very, very important.
Okay. Well, thank you. And after this short break, we'll be back and see some actual examples on screen of what ORM looks like and what it feels like to actually work some of the data and generate some of these database models.
Great.
Okay.
Thank you.
So thank you. Join us after the short break, and you actually see ORM in action.
Happy? Is there a Happy?
I think Happy should go, if anything.
No, why?
I would eliminate Dopey from the 7 doors.
Sneezy. He's unsanitary.
Can't be Doc, he's the connection, right?
Sneezy.
I'd get rid of Sneezy.
I'd kill the 4 I can't name.
Eliminate, meaning it not to be present in the scenario.
I cannot. I cannot.
I think I would eliminate Grumpy, because, he's always getting on people's nerves.
I mean, I love Grumpy because, I'm always grumpy too.
I think it would have to be Grumpy.
If I had to eliminate one, it would be Grumpy, for sure.
Dopey.
Probably Grumpy.
Most definitely Dopey.
But then we'd lose half of our team.
Yes, we would, in fact. Everybody know I love 7 Dwarfs. Kill Snow White.
Welcome back. And welcome back also, Terry, Pat, Dick. Now, since we've been talking about ORM, and since perhaps our audience isn't quite that familiar with exactly what ORM is, hasn't seen it before, and maybe you're having a hard time understanding how it applies to what they're sort of doing, I thought it would be a good idea to actually show them ORM in action and some capabilities. So what do you have to show us, Terry?
Yeah, I'd love to do that. So what I've opened up here is the employee sample model that comes with the product. So this model is quite small. We've split over a number of different pages. Let's just look at this page for a minute or so we can understand what it is that's being said. So remember, ORM is object role modeling. So all there are objects like employees, and then there are roles or parts in relationships. So here's like employee has a surname, employee has a first name, employee has a mobile number, employee has a room, or read it back the other way, the room is an office of an employee. Now these things here are called predicates or relationships. And when you touch them, if you look down the bottom here, I've opened up the verbalizer. So it's verbalizing not just the relationship, but also the rules that have been placed on it. So what we've got here, we've got a uniqueness constraint that each employee has at most one surname, which is this. And this dot here is a mandatory role constraint indicating that you must have a surname. Now this notion of mandatory can apply to a single role or it can apply to a set of roles. So here's the mandatory dot, put in a circle here, and it's going between these two roles. So this is an inclusive OR constraint. It indicates that it's mandatory that an employee play either this role or this role. In other words, you must have a mobile number or you've got to have a room. Yeah, maybe this guy's a contractor and you've got to get in contact with them that way. Or maybe a permanent employee's got a room with a phone number, you can get them that way. Maybe a permanent employee can have a mobile number and they tell you that as well. So it's an inclusive OR. I could do other things. If I wanted to make that an exclusive OR, I'd just select the predicates and I'd say, well, what constraint do I want to add? I'll have an exclusion on those two roles, thanks. Here's it verbalised in English, but it's probably easier on the big screen. So let me accept that. And if I touch that now, you'll see there's both the inclusive OR, you've got to have a mobile number or room, and also the exclusion. No employee can have both a mobile number and a room. Now, the way the constraints are done, they're orthogonal. So you can think of the exclusion constraint being overlaid on top of an inclusive OR constraint to give you an exclusive OR constraint. And indeed, these are considered independent in ORM. So I can actually just split these into two parts so you can see each part individually. And for example, I don't really want to make that exclusive, so I'll take that out of the model.
So what I'm saying here is you've got a flow chart you're manipulating of the data and the interactions between the data elements. Is that basically kind of what's going on?
Yeah, what it is it's just, here are the objects and here are the relationships between them. And here are some constraints I can put on populations of those relationships. It's a data model. It's probably one like many of you, we're not familiar with, but that's all it is. So let's move on to room. So a room is in a building and a room has a room number. So I put those two together and that's my primary way of referring to a room. Let's look at this one. An employee took a course. Now, talking about that coursework, so what I did here, I just made an object out of the relationship and I've renamed it coursework. Right? It's called objectification. Talking about that coursework, it can result in a grade and the possible values are A, B, C or F. Let's have a look at the room page here. So I've got a room, there is a classroom. That's something it can do by itself, a unary predicate. These things are binary because I've got two roles, these predicates. So I've repeated that fact up here on this page, and I'm going to say these roles are exclusive. So if you're a classroom, you can't be an office. So room, here I've repeated that. Come down here, I've made classroom a subtype of room. And here I've got a ternary association. A classroom for an hour slot is booked for an activity. And this uniqueness constraint here spans both roles, indicating given a classroom and hour slot, you can have only one activity happening. And I could do things like I could check out with populations whether that pattern really is unique, or maybe put uniqueness there. It's just totally generic. If you want to talk unary, binary, ternary, just say it the way you think of it. Let me show you how you might go about adding some facts to the model. I'll just, with this tiny screen here, I'm just going to open up a fresh page. And what I'll do, you could use the icons on the stencil here to do it, but I'm going to just put it in English. So let me just open up the business rules editor, and you see it lists the kinds of facts that we've got there. So here we go, we've got an employee. I'm getting thirsty, I'm talking so much. So that makes me think of drinking some amber fluid. So here we go. Let me, as you can see, I'm not the world's best typist. So an employee drinks a beer brand, which I'm identifying by a name, and read it back the other way, drunk by. Now I'm going to put some constraints on that. The tool prompts me, each employee drinks how many beer brand? What is it? 0 or 1, 0 or more, exactly 1, 1 or more. 0 or 1?
0 or more.
Oh, 0 or more. Okay, yeah. Great. Yeah, I'd agree with that. And indeed, if you can see it on this tiny screen, it's actually verbalised. Hey, you're telling me it's possible that somebody drinks more than one beer brand, and vice versa. So I can say, yeah, that's what I want.
Okay, so now on the first screen, you just typed in a simple statement.
Yeah.
And now this screen here is actually utilizing some logic it was able to deduce from that statement and displaying you some constraints to apply to it. Is that what's going on?
I could type in examples and have it induce the constraint. That's one way to do it. But I decided I would tell it what the constraint was simply by answering these questions. So let me let me show you how the analysis works. Okay, so we've got this fact type. Let's just drop it onto the diagram for a minute. And if I double click on this, I can go to the examples editor. And I'm going to start typing something in. Robert, do you drink any beer at all?
I do occasionally.
Okay, what would you like?
How about a Red Hook?
Okay. So Rob will have a Red Hook. I'm an Aussie, believe it or not. So I'm going to have a decent Aussie beer. And 4X is my favourite beer. Brewed in Brisbane. Okay, what about Pat? You have a bit of a drop of the amber, don't you? What would you like?
Sam Adams.
Sam Adams, yeah, that's not a bad one. All right. So you see, if the tool down here, so I can hit the Analyze button. When I do it, you might notice two red lights. Hey, the example suggests that this column's unique and this column's unique. In other words, it's one-to-one. But you told me it was many-to-many. So what's right? Now, if I say, well, these examples are significant, it really is one-to-one, I can hit the set uniqueness constraint and this will redraw it and it'll be one-to-one. But I know that it's not one-to-one. It's just my examples don't illustrate it. So I'm going to close that and fix up the examples. So, Robert, I'm going to convert you to a decent Aussie beer. All right, so we've got 4X there twice. And let's get rid of me. And Pat, you can have a 4X too if you don't mind.
All right.
So there you go. So I got Pat repeated here and I got 4X repeated there. So clearly that's not unique. That's not unique. So it's only the combination that's unique, which is what this is saying. In other words, it's many to many. So when I analyse it, yeah, it's okay. It's fine. That makes sense. There's no contradiction. So let me close that. Now one aspect of that, if I open the verbalize, you'll see what happens. Here's the fact type in English. Look, employee drinks a beer brand. Beer brand is drunk by an employee. What's this rule say? Well, it's possible that somebody drinks more than one beer brand and vice versa. Moreover, we've now got a set of examples that illustrate that it really is many to many. Now, we won't do it, but what we can do is we can grab all of this and put it into a report for the domain expert to validate. All they have to do is tick yes or no, do they agree with it. They don't even have to see the diagram. So this is a very, very safe way of getting things correct.
And in the field, we do that a lot. You know, we consistently take these reports back to our clients and have them verify the interviews that we've had with them.
Yeah, so these examples really do reflect what we want to reflect in the database.
Yep. Yes.
Oh, yeah, let's just have a bit of fun. Let me type employee smokes. I'll just add. So all right. So I'll accept that one. What else? Well, let me cancel out of there. So this is an example of a unary. Right? Some people smoke. I can just say it like that. I could grab this, and I could say, well, talking about that drinking. So if I let's open up the fact editor on that and jump here for a second. Let's just call that drinking. All right. I say, okay, I'll accept that. You'll notice it's made an object out of it. And so now I can actually go and say, well, all right, that drinking, what, feels good maybe? All right. So I say, okay, let me drag that one out. So I mean, maybe when Pat drinks 4X, it doesn't feel good, so he won't populate this. But when Terry drinks 4X, it does feel good. So I'm in that population. So you can see how this is just totally... Whatever you want to say, it just goes in, and it's fantastic. Okay, look, I'm going to save those changes to the model, and if this was all that ORM did, it's still incredible because I can see my data, what it all means so clearly, and it's so rich in terms of constraints. But it's not just that, it's executable. We can generate stuff out of this. So let me go and grab... let's create a new database out of this. So let me open up a database model diagram. And I'm going to create a project, and I'm going to add that document into it, which we called EMP. All right, so in it goes. Let's move you out of the way. All right, now I'm going to actually build that project. Now what this is going to do, it'll prompt me, what do you want to call that? So let me call it, I don't know, Project Hess, after Robert here. It's going to grab those facts and work out how to group those facts into relational tables in fifth normal form you get by default. So here they are here. All right, here's a bunch of tables. So I can just drag these out now onto the drawing window, and there they are. Let me just group them a little bit closer together for you so you can maybe see a bit more when I bump up the magnification. All right, so let's have a look at that. All right, so what have we got here? We've got the employee member that smokes, and it comes here as a attribute in the table. I guess I should explain the notation briefly if you're not familiar with it. So these are obviously the table schemes. Anything in bold is mandatory. So it's optional that you've got a mobile number, for example, but it's mandatory that you have a first name. For the coursework, it's optional that you've got the grade, and so forth. The PK is just a primary key. The FK is indicating foreign keys. Here's the foreign key relationships here. Okay, here's this U. Remember that for a project it was 1-to-1, so both the project number and the project title are both unique. So this is indicating that that's unique. So I've just taken the defaults here. We can actually control the way these names get generated, but let me just accept the default here. Now, for those, if you're familiar with and like just pure relational notation, then this is the best way to view it. But the tool actually lets you view it in other ways. So if I...
also, what I'm seeing here is that you started out just doing an English type of statement about what was going on here. And then you took and brought that into the ORM flowchart sort of model and verifying what's going on, drag and drop things, checking things out. And now you're actually created, this is a set of tables that we're looking at here.
It's still an offline model. We haven't generated a physical database yet.
But you've actually defined the tables. I mean, like
this
in
is right.
ORM, you weren't actually talking about tables at all.
No.
You're just talking about the needs of the thing, and now I've actually got the table stuff set up.
Yeah, if you think about it, I mean, the model is sitting down with a domain expert. Their job is just to figure out what is this application domain that we're talking about. Give me the data semantics. It's irrelevant how this stuff gets implemented at that level. Right? So if the tool can implement it for you, you don't have to worry about it.
Yeah, in the field, we actually fill a very important role because there's this gap between how the business thinks about their business and how a programmer has to think about the solution to implement that business. And so we're the glue, if you will, that will bring those requirements into a model, and then we can communicate effectively with the programming and development team.
So let me, the developer has to work directly with tables. So they'll want to see a diagram like this. It's just the domain expert that understands the business. They don't want to see anything like this. They're happy with the ORM representation.
I mean, I look at this and I really can't quite understand exactly what's going on from the original problem space. I might be able to look at this and say, okay, I understand in a database, here's how this data is going to be blocked around and how the different pointers are going to be.
Right. The other thing that's lost here is all those, many of those business rules. So what happened to that inclusive OR constraint, for example? I can actually view it here in the model, but not on the diagram. I can go in and I can click on these things. And for those that just don't like ORM and just want to work purely relational, you can. All right, you can just go in here and have a look. For instance, there's a check clause we generated here that enforces a constraint. We'll have a look at that later in the proper DDL. But there's also requirement in some of the guys at Patton, Dick in particular, work with the government things. And some of these guys say, well, look, I need my models in IDF1X because that was a standard that had to be specified for various things. So you say, all right, well, that's just an option. Well, let's go to the document options. So you want IDF1X? You got it. All right, let's have a look at it. And so now it's automatically redrawn, and it's an IDF1X model. And some other people say, look, I can't. I don't particularly like that one, but I do like information engineering. So let me go over there and choose the crow's foot notation, and now we've got information engineering notation with the crow's foot for many and so forth. So you can have a great deal of flexibility in terms of how you actually present these logical models to clients. Let me go back. I prefer, to be honest, pure relational. I'm just going to switch it back to that.
Now, some people would actually design their database at this level.
Here you can, and if you're very, very good, you can actually get it right. But if you're not the greatest genius in the world, it's so easy to get it wrong. I mean, there's a whole theory of normalization, which is a little bit complex, like, what's the difference between elementary key normal form maybe and voice code normal form, and some people get confused about these things. You don't have to agonise about any of that stuff. The tool gives you fifth normal form by default. If you want to denormalise, okay, that's something you do consciously. If you want a fully normalised database, you get it for free. Let's I guess we should go down and generate some physical DDL for you to show even though it's an offline model now, we can actually do the real thing for you. So the next step would be to generate. If I had already built this and made changes, I'd say update, and I'd be generating the alter scripts. But we're building it for the first time, so I'm going to say generate. All right, and I have the choice. Just generate the DDL that I can pick up and execute in SQL Server, say, or if I've got a connection, go and generate the new database for me. If I pick that one, it actually makes a backup copy of what I've got, so it remembers what the model was. So when you make changes later, it knows how to synchronize things. But for now, let's just go ahead and generate the DDL. So, well, I prefer SQL Server, okay? But some people like other things. Maybe DB2, maybe Access, maybe Oracle. Or for other ones, pick some kind of ADBC generic driver or whatever. And you've got options with setup. So I've actually set this up for SQL Server 2000. The tool goes back to version 6 of that. So let me just accept that, and let's call it Hess DB. That's the database we're going to generate. So I'm just going to jump through. It says, hey, look, I'm going to build all these tables for you. One of the constraints you gave me spans tables. Could be very expensive to run that one. I've got to do natural joins between the tables to check on that one. I'm going to wrap that up in a stored procedure for you, and maybe you can run that one in batch mode, or you decide. All right, so off we go, and let's go and have a look at the script. All right, so here's this Hess DB that we just created. All right, so let's have there's that drinking one. All right, primary key is the employee drinks the beer. Okay, well, here it is, all commented for you, so you know where it came from, and then feels good. That was a unary. Well, this is implemented by default as a bit, true or false. So let's jump down, and there'll be a foreign key, of course, from the employee here to the employee field in the employee table. The foreign keys are done later. Here's the room booking. That's easy enough. Let's jump down here and just focus on what happened to some of these business rules. There's trivial things like the ratings between 1 and 7. Okay, see this exclusion check. Remember the rule that we had at ORM? No employee may manage and evaluate the same project, which is easily understandable in English. What is it in the DDL script here? It's evaluator employee number is null. That means, well, it hasn't been evaluated. So either that's the case, or, okay, it has been evaluated, so what do we want to happen? Well, the manager employee number should be not equal to the evaluator employee number. So you can see how the code got generated to enforce the constraint.
So that's definitely code that a programming language could understand, but maybe a person wouldn't quite understand anywhere near as easily as would in generating the program.
Yeah, somebody familiar with SQL will understand it. But the domain expert, where you're getting the rule from in the first place, might know anything about SQL. And what's this null business? He hasn't even heard of that. So by crikey, I don't know what you're talking about. So ORM frees you from all of that. By the way, one of the key things about ORM is it's attribute free. We didn't kind of mention that. Right. You don't choose attributes in the original model. There are many reasons for that, but one reason is to avoid null values when you populate things. So that's basically shows you, in a nutshell, how you can express an ORM model at a high level, validate it with a domain expert, just using plain language examples, put your business rules in where it's so easy to think about them, be unrestricted in the way you talk about it, unaries, binaries, ternaries. If you want to make an object out of a relationship, just do it. Right? Push a button and just go all the way through. Here's all the DDL code for you. I mean, what more can you want? So that's the forward engineering. I'm going to stop my demo there, but what I've just mentioned is the tool is actually fairly powerful. Even though we recommend if you're making changes, you should make them at the ORM level first, where it's clear, and then just keep on propagating them downwards. Not everybody's as disciplined as that. So we actually allow people to make changes at the ORM level, at the logical level, or even at the physical level, and we will keep those changes in sync. All right? So not only can we reverse engineer from existing databases up to ORM or up to a logical model, but we allow you to make changes at the different levels and propagate the changes to the other levels, and we keep track of things so we know when these things get out of sync. And then when you actually have the tool do an analysis for you, it tells you what's different, and then gives you the choices of, do you want to refresh the model with changes you made in the database, and so forth. It's quite a powerful environment. But I'm going to finish up my demo there. You've got the basic idea of forward engineering. I know Pat and Dick are going to illustrate some of the reverse engineering work with their demo. So did you have any more?
Well, one thing I know that as a programmer, if I'm wanting to interrogate a data structure, quite often I'm using XML for doing that with. I load it into my XML DOM, and then I can take and walk through that structure. Does ORM allow the capability of actually exporting XML that I could deal with at a programmatic level like that?
Yeah, that's a good question. We've had lots of requests from customers for that kind of feature. The tool currently does not provide an automatic mapping from either the ORM or the logical database model to XML. There is an unsupported COM API that we've got with the tool, so you could basically do it yourself that way. But fortunately, some of our consultants have been wanting this to happen for quite a while, and we haven't done it for them, so they've actually gone ahead and done it themselves. For example, Scott Becker of Orthogonal Software is about to put up in a few weeks' time a freeware add-in to the product, which actually provides a translation from either the ORM model or the logical data model to an XML schema. So that's, you get to download that free plugin, and then you can play with the XML representation and build your own things on top.
Okay, I'll make sure I get a link to that, to where that download's at, and put it on the transcript so people can actually download that right now. Since we'll be hopefully having this episode available after the fact, if you're saying it's in a couple of weeks, so it should be available then.
Yep.
Okay, so why don't we take and get on to the next demo then, and see what you've got to show us, Pat.
We're going to step into the Northwinds database that comes with SQL Server. And
probably all of our audience is well familiar with the Northwind database by now. It seems to be used in every example there is out there.
Right, but we've not only going to point out some issues with it, but we've also intentionally done some other damage to it, is probably the right way to say it. We took some relationships out and some other things. The reason for doing that is we wanted to give a picture of what happens when someone comes in and there's an older database sitting around and they want to improve it, they want to correct it, and they probably want to add something to it. The business is changing. And so we've made this model represent some of the typical issues that we'd find. You might not find it in a model this small, but when you're looking at a large model. So we intentionally altered the Northwinds database a bit, and we'll put it back together and we'll make some changes to it.
So the key here is that ORM isn't just from a start-from-scratch database modeler,
right.
But this is actually, if you've got an existing legacy database you're trying to deal with, you can take and now import this into the ORM moving forward. And chances are pretty good, I expect, you can actually improve upon what the original database was, even if you're not adding anything.
Yeah, that's one of the goals when we come in to do that sort of thing. And, if we get to come in and do a brand new model from scratch, we've sort of died and gone to heaven. We usually come in because there is something to be done and something already exists. And there may be several databases that you have to go through and do these sort of things with. It very seldom are you lucky to get something as small as Northwinds. And with that, I suppose we can just
dive
in. Get going on it. I have SQL Server open already, and we're to the damaged Northwinds database.
Yeah, so Pat's brought up the logical model of the Northwinds database in SQL Server 2000, and we're just going to make note of a few issues here. One is the customer demographics table. Now, you notice that there are only two columns to this table. There's the ID, and then there's also a customer description, which is null. It'll allow nulls. So, it really doesn't make a lot of sense. You just look
have
at
a null
that.
customer.
Yeah, you have an idea of for, right? Well, what does for mean?
Yeah, what does for mean?
Yeah. Well, it means for, right?
Yes.
Well, no. Right. So, and it's not tied to a customer, so it's just sitting out there all by itself. Another example is the actual customer table itself. If you look at that, there's absolutely no referential integrity, or what we call RI, to anything else. In other words, it's another table that's just hanging out there in Never Land.
So meaning by that, I don't see any links between that table and anything else within the database structure at all.
Correct.
Just like a free-floating phantasm or something.
Right. So in other words, if you had another table that referenced customer, like an order, right? Well, essentially, you could put anything in there you wanted to. It wouldn't be validated against the actual customer table. Another example is the employee table. Again, here we have removed all the referential integrity just to illustrate this, and also there is a ring constraint in there in the form of a self-owning join there. And what we'll illustrate on that is just the whole notion of actual constraints on the data that enforce the integrity of the ring constraint itself. So that's one of the things will be, next one will be region. Okay, in region, we have very limited referential integrity. It does have referential integrity to the is that the territory table? Yeah. And also, the other thing to note on a lot of these tables is, for instance, when we do go to make up the referential integrities, is that the data types are out of sorts. In other words, how we identify a region as integer. And then if you look at a table that references the region, it's in there as varchar. So, we're definitely going to have some problems there. All right, so
how many of these problems are ones you actually whacked the Northwinds database to create? How many were actually part of the original design of the database?
We took out some of the customer relationships and the employee relationships, and up to customer demographics. We destroyed some of the relationships. For the people who do modeling, look at a lot of databases, they'll have to smile about that a bit, because we encounter this a lot, where they've left it up to the application layer to worry about how these things are. Is this going to be valid or not? And they're leaving it up to the application rather than letting the DBMS do it. And so sometimes it's done intentionally, and sometimes it's done by mistake. And we wanted to demonstrate that kind of problem, so we created it. Mm-hmm. The data type ones, however, that Dick was just speaking to, were inside the database already, where you would want that referential integrity. In fact, it had been. But the data types are totally different, which says that there's going to be a problem when you want to go about doing this.
So essentially, we've got a database that parts of it were, it's an example database we've been using for years, and yet the database itself had some design flaws.
Yep.
The looking in SQL, we can see them here in SQL Server, but they don't really jump out at us and force us to fix them.
Now, one way we can illustrate how you would actually detect that is we're going to jump to an example of reverse engineering.
We're going to shut this down. And
a very exciting desktop background I saw there. It's like nice single solid color. You should get a little picture back there or something like that. Just
there you go. I used to have a little ORM thing in the background. Okay. It had all kinds of little shapes on it.
So what Pat is going to do is open up the Visio Enterprise Architect tool. He's going to open up an ORM source model, and then he's going to reverse engineer. So he's going to connect to the database and then pick up the attributes that he wants to.
I'm not going to pick up stored procedures and everything else. We'll just pick up the actual data.
Mm-hmm.
But you could have picked up a database that had stored procedures, and it would have probably been imported.
Yeah, we could have picked up several things, but we just want to look at the tables. Now, this will go directly into ORM in this particular case.
So when he does this, you'll notice it's reverse engineering. Now what you get is a list of all the facts that make up this model. And you can see them in the bottom right-hand dialog box there. So what he's going to do is drag the fact about the demographics out, and we're going to zoom up on that.
Zoom up.
So you can see that a little bit better. Now, what's very interesting about this is that notice that back in the logical model, this thing just kind of stood all by itself. We can double check that by right-clicking on the actual demographic, customer demographic object itself. And you'll see where it says show relationships. That will show all of the related facts to customer demographics. Notice that it's coming up with absolutely no other facts related to customer demographics, which means it's not hooked to anything.
Mm-hmm.
So now if we bring back another fact, say about customer, and we put that on there. Now let's right-click on the customer and show the relationships. Now what it's going to do is start bringing in all the facts about a customer. So you can see that there's customer has a much richer definition than customer, and it's actually hooked up to quite a bit of stuff within the database. So this is a really a fundamental way to actually start doing some analysis on the model itself.
Yeah, just to chime in on that. When I reverse engineer, what I often do is actually open up the object type pane rather than the fact type pane and drag an object of interest onto the drawing surface and say, show me what you do in the universe.
So if we just
Yeah, and every table that you had in the original physical database will appear as an entity type in the object pane. So you immediately see these things, so you can top down that way.
So here's an example where we just dragged the object out, and now we're showing all the facts with that object.
And then you can just select any other object and do the same thing. And you can just progressively expand the universe up that way. But anyway.
And for instance, this is what would be like, say, page 1 of it, and we would call this the customer subject area. In other words, to people who are associated with data management, subject areas are very, second-hand. You have a subject area for each thing. So we can go ahead and create another page, and we can have the employee subject area. And we can do the same thing with, drag the employee up there and put all the facts out for that employee. So, this is a very nice way to actually build up the modeling and be able to compartmentalize it so that we're not talking about too many different things all at once on the same page. So now we're going to pull a cooking show bit here, and we're going to close this down and open up the new and improved.
So from oven number 1 to oven number 2. And
yes, that's right. The completely baked one. Right,
So I'll get back to the first page.
So now we've got the new and improved Northwinds database, and we're back onto the customer page. Now what we've done is
and what exactly did it improve this from the original one?
Well, those were all the issues that we had talked about before.
And then you took and actually within the ORM modeler, you took and cleaned those up. You created the connections to the correct tables and the correct references.
Yes, and so what we've done here is we've highlighted in yellow exactly what you just talked about, all those things that we did to actually improve or correct the model.
So everything's in yellow you change, or
yes,
change.
That's correct.
There's an awful lot of things in yellow there.
Yeah. Well,
Well, if you're looking at location, there were several tables on the other side that used address, city, country, and postal code, and we said, well, we're talking about a location, so let's just since we're talking about a location, let's introduce the word and then say, well, what makes up a location? Well, it's the address, city, country, postal code in this case. And so the idea, we put that together and we gave it this primary key over on the side which says, this is primarily how I identify at the conceptual level. This is how I identify a location. So now anywhere where I want to use location, I'm going to get the same definition of location. It's always going to be the exact same columns, the same data types, the same structure. So instead of having to rely on the modeler making sure that if he wants to do this in more than one table, that he gets it right in both places, we create this sort of complex object and say, now just borrow it. It already exists. Just borrow it and use it over here now. And then you know it's exactly the same as it was before. And I can even take it to another database for that matter. We use it in this database or take it to another one. It'll still be the same thing.
Yeah, when you emit the database out of this, does it then create a location table thing, or does it still end up creating address, city, country, and postal code?
In this particular representation, we chose to let the columns go into the tables that care. We can make some small changes to this that would say, no, we really want to create a location kind of table, and we really want to manage that as a separate thing. And then there'd be a referential integrity between the tables that want it and the location table. That's all part of the conversation that you can have. We chose this one because it represented closer to what Northwind was, and we wanted to show that we can get back to what Northwind had by taking some things out, redoing them and putting them right back. But we're doing it differently. There's some other things on here.
And now notice the region up here. This is what Pat was alluding to a little bit earlier. Before, when we talked about the logical model, region was an integer in its region table, but then it was a varchar in the other tables where it referenced that region, but there wasn't any referential integrity between them. Well, that causes a huge problem when you're trying to build up those kinds of rules or referential integrity in the actual physical database itself, is dealing with those disparate data types. Well, we can fix that by just simply defining region once, okay, and it becomes a much more robust and well-defined domain within the data model. And then, from then on, no matter where it's used, it's going to take that definition from the data model, from the object role model itself. So, just with one fell swoop, we can fix all those problems right away. The next one is the phone. Okay, so there's the phone. We've made that a domain, okay, and then we have it play a number of different roles. Okay, the next one would be person name. There again, we're doing the same thing. Okay, so we can use that in customer, and we're also going to use that same person name in employee. Right now, you don't see the complexity of person name, but when we get to the next page, you'll see exactly what I mean. Then we took the whole notion of the customer demographics, and we changed that into a customer type. Okay. Along with that, we also fixed the whole problem of having a optional description for that type code and made it mandatory. And also introduced the whole idea that if you're going to have a description for that code, that the description also has to be unique. In other words, we don't want to have the same description for different codes. Because if we get into a situation where we use the description in a drop-down, we want to have uniqueness. Okay, we've gone on to the next page, the employee page, and here's what I was alluding to a little bit before, the whole nature of person name. Remember, on the previous page, all we saw was the object person name. The detail of it wasn't exposed. Now here on this page, we can see the full definition of person name. And that kind of will give you, right there, that'll kind of give you an idea of the power of being able to reuse that object, because you can just place it on any other fact that you want to, and you can be sure that the definition is going to be consistent across the board.
And location.
And then, of course, there's location again. And here's just the reverse, right? Here we just see the object location without all the detail behind it.
I'm just saying something, someone that's familiar with object-oriented programming is going to understand this model very well, because it's object-oriented database modeling.
That's right. And some of the benefits of this is that we introduce consistency, of course, data integrity. We can populate the drop-downs consistently. We can actually influence the integrity of dimensions that we might place into a data warehouse application. And in the turn, because we can do that, that eliminates a lot of the data cleansing problems that you have when you're trying to merge data from a lot of different areas. Then again, there's the phone. And in this case, we're using the phone in a couple of other different kinds of roles. Not just primary and fax, but in this case, with the employee, it's a work phone and a home phone. Yeah, so there's another illustration. And, of course, here's date. Date we've just made simply a object in itself with a reference mode of month, month, day, day, year, 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 year. So century, century, year, year. And from now on, when we use date anywhere in the system, it's going to have that reference mode, period.
Yeah, are you differentiating between Gregorian date and Julian date? And
yeah, in this case, it's just purely a date with that reference mode. And we can put any reference mode.
In that model, let's say I was using date throughout the thing, and later on I decided I needed to take, since I was using this thing that crossed many centuries of a database, and I wanted to go from Gregorian, I would just have to go one location, change the definition of date in one location, and it would propagate up.
That's right. Yeah. Now, notice the other thing that we've actually introduced into this model. We don't have it actually highlighted in yellow, but remember I talked about the self-owning relationship that we had on employee.
Yeah.
Here we can actually get into a lot more detail about this, and this is in ORM is called a ring constraint. And this actually defines the allowable set of data populations that can actually exist in the predicate. So, here we can see the verbalization of it.
So the verbalization says an employee cannot cycle back to itself through one or more applications of the relationships, employees managed by employee.
Yes.
And so that is not something someone typed in, but that's actually something that's coming out of...
Yeah.
Right.
I mean, every verbalization is automatically generated. Nobody types those in.
Right. And I think I'd probably hate to see what the SQL Server definition of that looked like.
Actually, this is kind of a neat little feature of the tool, because you're talking about how this set plays with itself, and we said it's acyclic. These are kind of technical terms in this particular case, but all these are all the only ways that sets can actually play this particular game, and so these are the only legal combinations.
Yeah. I actually designed this UI, so even though it looks complex, I like it. It's actually quite complicated. The general problem of making sure your constraints are consistent. Like you could put in one ring constraint which is maybe inconsistent with another one, and we can up front stop all of those errors through this user interface, because you're allowed to pick just one of these things. And we even look after, this is actually acyclic and intransitive, but we know that because of this uniqueness constraint, it's a functional relationship. So this actually implies intransitive in conjunction with acyclicity. So there's no need to generate code for intransitivity. If you've got the uniqueness constraint enforced and acyclicity enforced, you've got intransitivity for free. So the tool basically looks after all that for you, and most people would just get lost on this.
So, what we're seeing right there is it looks like a Venn diagram or something like that.
It is a Venn diagram.
So you're selecting, this is the model, this needs to apply.
Yeah, actually, to be strictly correct, it's an Euler diagram. Essentially what you're saying is correct. Yeah, you say pick out what it is that you want. Yeah. Mm-hmm.
And if you get a conflict of the rules, the tool comes back and says you've got the conflict, and then it tells you why, and then you can go take off the conflict.
and then again, just to illustrate, hammer home the point that the user, the business person doesn't have to deal with all this stuff. They can just deal with the natural language of it. Right. Mm-hmm. Let's go on to the next page. This is the order detail page, and here one of the things we want to illustrate here is that we've created reference modes for a lot of our numbers. Okay, so discount is expressed as a percentage. Amount is expressed in U.S. dollars. Quantity is expressed as a number. Okay, and it's really, really important to recognize reference modes. Probably one of the greatest illustrations of botched reference modes is the Mars debacle. Do I need to say anything more, right?
So if NASA was using ORM, they wouldn't have had that problem.
They wouldn't have had that problem.
No, they wouldn't.
No, they wouldn't. The others here are just really quick. We We've just made some other additions. I left this one over here as red, colored it red just to take a second to go in here and say, well, what's wrong here? I want to get to the examples. This, in its current form, allows me to say Region 1 can be Boston, and then there's some others, and then Region 4 could also be Boston, because there's nothing in place to prevent me from doing that. But one of the things I could do is I could say, well, I want to go here and I want to look at these constraints, and I'll just take the current one and remove it, and I can go back to the examples, and I can take this one that says Boston and change it to something like New York, and say analyze that for me very much, and it says, okay, now there's a constraint over column 1 and there's a constraint over column 2, and I'll say go ahead and apply them, and now I'm back to what I want. So I just used...
This was like situation using the beer example previously.
Yeah.
Where it kind of said, I see everything's unique. Is that what you really want?
Yeah.
Right.
And we said,
That's right.
no, that's not what I want. But in your case, you said, that is what I want. I want uniqueness going on.
And
we
you
had
can
the...
see the one-to-one on the... It's drawn it
Yeah,
immediately for you.
we changed our mind and said, no, that region, we can't have two regions called Boston.
Right.
Evidently someone else thought they could, and someone else came along and said no. And so we can just change the example and say, okay, now reconstrain the rules that apply, and it'll do it for us. Okay, and apply.
Okay.
Now we're going to shut this down.
Now we're going to go to, North Winds has been growing. Okay. So we've got to change along with the times here. So we've created a supplier plant enhancements to Northwind. Okay, and now notice that we've got a number of objects on this diagram, on this object role model, that are highlighted in yellow. All of those objects are in the other model that we just closed. And we can borrow the definitions of those objects and place them into this model when we do the merge.
Because if you come here and look at it, if we look at reference mode, it knows a little bit about it and stuff, but it's in a completely different place.
Yeah.
So all of that detail is hidden. You don't really need to know about it at this point in time, but you can go and get the detail.
So you can just reuse all those components that you've predefined in some other model.
Yep.
And if the company wanted to say, hey, here's my reference model, and pre-populate it with a whole bunch of predefined object types.
So again, that's very much like object-oriented programming.
Right, you can just...
Yeah. And the beauty of this is we're not redefining them again, right? We're borrowing that definition. And, we're getting all the characteristics and all the properties about those other objects. And we've got a couple of new facts here. Employee worked in a plant, works in plant. We've also got plant exists at location. So we're borrowing the employee and location object. And we've introduced a new, very complex, I wouldn't say very complex, but we've introduced a ternary. Supplier provides product to plant. Okay, and so the new object that we've introduced to this sub-model is the whole notion of plant. Okay, and what happens in a plant and what happens with a plant as in relationship to other objects in the enterprise. Okay, so this actually is how we actually build up models when we do enterprise modeling, because there's going to be a lot of different subject areas across the enterprise, but we're going to want to consistently define objects that are reused across the enterprise. So,
and the hashing here, the yellow brought it out, but there's also, you can notice a hashing through that yellow. That is the normal way of saying this object is from somewhere else. And we happen to make them yellow here just for emphasis.
So notice that we've taken the one last thing. We notice we've taken the ternary there, and we have objectified that and turned it into an object in its own right. And now we can talk about that object. So in other words, the whole idea of plant supplies is that thing has a contract date where it starts on, or until it goes until to. It expires on a certain date. So we can always extend the model that way. Well, now we're actually going to merge these models into one unified logical model. Okay. So Pat's going to open up. Let's just pretend we've got the pie bit right. We put it in the oven. Okay, now it's cooked up. And so here's the resulting model. Notice in here we've actually color-coded this. Now, the entities that show up, the tables that show up in blue, are the ones from the new and improved Northwind model. Yep. The ones that show up in yellow are the ones that were just added by our supplier plant enhancements. Okay, so you can see how everything is getting tied together.
We didn't change. There are naming conventions that we can allow, but when we first build this, we quite often don't concern ourselves with it, because reading it now is quite comfortable. I can tell that I got location from, and location is going to give me the address, location is going to give me the city, etc. And down here, the contact person name, includes first name. I'm getting pretty close to still using a lot of the verbalization. I haven't filtered out words or given it a naming convention, and I don't need to do that until fairly late in the process, where I say, well, now I want names that are more like what programmers are really going to use, and I don't want these things added on. So we can control the naming later, but right now it's very handy to say, well, why is that column in there again? It's a little terse, but it's a pretty good explanation as to why things have gotten there.
In other words, avoid the cryptic naming until you don't.
And then plant has the address as well, but we said plant exists at a location, and notice it's picking up a little bit of that predicate, and it's saying, well, it's because you say it exists at this location. And that's very handy when you want to do the early reviews of essentially an ER-style diagram. It just lets us go in and look at it that way.
I think that shows some important aspects of ORM, both from the standpoint of building something from scratch, what it means like to use the verbalizer and construct the diagrams using Visio, as well as taking a legacy-style application and then importing it through and providing the additional functionality.
Exactly.
Now, one question I have when I was looking at this, a lot of developers out there using Northwind database for various demos and junk like that, and they might write this little VB application on the side that is touching into it.
Yeah.
Now, let's say you went through this exercise and you cleaned up Northwind database from a legacy model, and I wrote this VB application. Do I now need to rewrite my VB application to utilize your new model, or could you have done the ORM stuff in such a way so that it would have been totally transparent to me, the database just now would work better?
You're going to have, at least at some layer between you and that application. First of all, the application will have to change for anything that's new. And it depends on what strategy you use to protect yourself against database change.
Granted, I suppose the one change you made was here it's an int and here it's a varchar. If I wrote code that was specifically using that as advantage, if you're going to correct that mistake, I'm going to have a problem.
So you can use techniques to actually insulate yourself, like for instance, just using strictly views. Always use a view to actually get to the database itself. That will actually protect you.
So if your goal originally was to take and update the Northwind database in as compatible as possible, so you fixed the mistakes that were there, but you didn't really add any new, you didn't add the plant supply and stuff like that, you're just basically fixing the Northwind database, then as long as I wrote my VB application in a proper fashion, all those changes would be transparent.
Yeah, an example of that would be where we took the address and changed it into a location, but let the columns come right back in. But we created ourselves this location object so we could reuse it and be guaranteed that object. It would turn out that the table actually is going to turn out to be the same, and so there's no real impact there, except we at our level have gained a real advantage of knowing that now when we say location, we don't have to worry about all those attributes that go with it. We know what's going to go with it.
In the future, when somebody wants to use that location,
they can reuse it simply.
They just
So this looks pretty exciting, and I can see a lot of people. Hopefully, the audience out there. Most of my audience is real developers and stuff like that, and using C# and VB.NET and stuff like that. But I expect they might catch on to this. But chances are good to also have some database people out there looking at this, and maybe they were never even aware that ORM was something that was an option to them. So, what do people in my audience need to do to actually use ORM? Where do they install it from? How do they get it?
Okay, well, the tool that you've been seeing demonstrated is part of Visio for Enterprise Architects, and currently that's available only in Visual Studio Enterprise Architect. Actually, when you do the install, it's easy to miss it because it's actually on a separate D all by itself. And after you do the 2-hour install, in half a second, up comes a prompt saying, "Do you want to install Visio?" So if you miss it, you probably don't even know it's in the product. But say yes to that, and you've got your Visio.
So if they've installed VisualStudio.net, and if through that installation they also added Visio to it, then they've got your product installed.
Yeah, and what they should do is install the service release. So I think you'll provide a link to that. But yeah, there's a service release that we've already put out for the product that includes. You got to realise that this product's built on top of Visio Professional, so they did a massive number of improvements and even some new features, plus a lot of bug fixes. And we took that and built on top critical bug fixes and so forth ourselves, and that's been wrapped up into a single service release. And they basically install VisualStudio.net, make sure you install Visio. You can do that later if you didn't do it the first time. Just open up the install again and just say, I want to add that bit to it. Then install the service release 1 and you're ready to go.
Great. I'm sure I'll go back to my office right after this and make sure that I've got it installed in my system. Work up a recipe database or something like that.
Why not?
We'll be glad to help. Put the fun back into modeling.
That's right. Okay. Well, are there any closing words you want to take and leave our audience with in key aspects of how to understand ORM better and get more information for resources and such?
Yeah, I mean, I've got a website, orm.net, and it's got about 50, 60 papers you can download on it. Plus, for somebody who wants to actually use the tool, you'll find there's a series of articles that I've written on actually how you go about and use the tool to build models. So there are 5 or 6 articles up there. There's also copies up on MSDN. So there's a bunch of resources. And you guys have got a whole journal, online journal, and another site, inconcept.com, devoted to it.
Yeah, actually our website is www.inconcept.com.
Okay, and I'll include a link to that in the transcript as well.
Yeah, and they can, the journal is open to a number of people. If someone gets interested, they can write and, get a hold of us. They can write an article to it.
Yeah, there's a forum there, a discussion group, pretty active. There are links to all kinds of other sites from our sites. So.
Well, thanks. Thanks for joining me. I learned an awful lot about database modeling and about a great little product here that I probably have installed in my system already and just didn't know about it.
Yeah.
So
okay.
Thanks for joining us.
Good. Thank you very much. Thank you.
So hopefully that gave you some insights on this ORM model for developing databases and applications with. Now, granted, most of you guys out there are probably developers, so there are probably a few database people. Yeah, there's a couple out there I see. This is a tool you can use to help you understand databases better, work it into your applications, and hopefully even create and correct databases you might already have in your enterprise. So hopefully you learned something here. Thanks for joining us.
So some of you have posted comments saying that you would like to see Robert and me interviewed in these interviews. So today we have a surprise, and Robert Hess is going to be my victim interviewee today.
Victim, I like the way you put that.
Yeah. Robert, welcome.
Glad to be here.
So everybody knows what you do on the .NET Show, obviously, but tell us what your main job, your real job at Microsoft is.
Well, my real job, I work for a group called the Platform Strategy Group. Our group focuses on thinking about the overall platforms that Microsoft is producing and helping to articulate to outside developers as well as internal developers sometimes, what those platforms are and what is the best way to take the best advantage of it. We look at different technologies coming out, whether it's .NET or whether it's some of the new storage technologies or some of the graphics capabilities, DirectX or whatever, and try to figure out how an ISV can write an application that provides their customers with the best possible solution using those technologies.
So you probably work with a lot of partners?
Yeah, we do.
Travel?
Yeah, we travel quite a bit. I talk at various events and doing demonstrations of what some of these technologies are. We have a lot of partners that come here to us to see some events here on campus and talking to them. Plus, our team has a group of people that's their key focus to actually go out and talk with these people. My particular group is focused on actually writing sample applications and prototypes and demonstrations. Because quite often when you hear someone just kind of rambling on and talking about some technology, it's really kind of hard to understand until you see on screen that, okay, what I'm talking about is you can drag this item here, drop it there, and this is what happens.
Yeah, it's more powerful.
Yeah.
So what did you do before your current job?
Well, before my current job, I actually worked at MSDN and put this show together, and that was a lot of fun. But overall, my career at Microsoft, I've essentially been doing the same thing for almost the entire career.
What's that?
Basically, helping outside vendors understand our technologies, talking about what our future platform is going to look like, what they have to expect coming out in the future. So I was talking to people about Windows NT while Windows 3.1 was still in the release phases and that sort of stuff. Then prior to doing that, I actually was a developer on OS2.
Oh, yeah?
And that was a lot of fun. I worked on the palette manager for OS2. And so it was interesting to kind of see that other side of the project and actually having a product that was delivered at some point in time. And ever since then, it's just been more like I don't really deliver any products anymore. I just, deliver the show.
Well, this is a product,
in
a sense.
Product. Yeah.
So what do you like to do outside of work?
Well, outside of work, I've got a number of different interests. I mean, various aspects of cuisine has always interested me. I've always been into, French cooking and cooking of, Mexican or Indian, regional areas and that sort of stuff. I also spent quite a bit of time learning about wines as well as beers and so forth like that. Lately, I've taken in this aspect of cuisine and wines and beers has kind of evolved into another strange step that has been kind of a hobby of mine for the last couple of years.
What's that?
It's a little bit different. Cocktails.
Oh, really?
Yeah.
Cocktails.
The way I think about it is that, I spend awful lot of time studying about wine. And, Cabernet Sauvignon, Bordeaux, Chardonnay, all the different types of wines. I could recognize bottles, stuff like that. But it seemed no matter how much time I spent studying wine, there's always someone else that knew more about it than I did. I mean, there's always something more to learn from that standpoint. And another aspect was that you go to any restaurant and you see that bottle of wine on their wine list, and it's going to taste the exact same way that same bottle of wine tasted over there. And so the quality of the restaurant really didn't impart itself upon the wine you're drinking, other than maybe their selection. So one store might have a different selection and stuff. Where a cocktail, on the other hand, not only do very few people really understand cocktails, and so I was able to kind of, get a jump up on things there pretty quickly, but also cocktails are a participatory experience. You actually, the bartender, it's his ability to mix the ingredients. Once he's got all the ingredients available, it doesn't matter how good the quality is. If he mixes the drink wrong, just like the chef back in the restaurant, if he puts the ingredients wrong, it's going to taste terrible. Where understanding the cuisine and the quality of the cocktail, I think, is really important. And so that's been kind of, my issue of moving forward is trying to understand the cocktail and all of the cuisine aspects of it.
So basically, you've been treating liquor like a science.
Yeah, like a science and a cuisine. Yeah. Yeah. I mean, one of the things that bothers me the most is these people that seems their main interest is, do you know a drink that'll get me drunk really fast? And that's just, grates on my nerves because, a drink isn't meant to be drunk just to get drunk. I mean, it's like eating. I mean, if eating was just to get full, we'd all be going to, these all-you-can-eat buffets all the time. But, eating is an experience where you taste the product, you understand the product, and you can actually appreciate it without actually getting full, perhaps. You get a pleasant experience in your stomach, but you also get a very pleasant experience from a sensory standpoint.
But except for maybe some cordials, when you think of cocktails, it's not really something that you consume with food. At least to me, wine, of course, pairs with food very well. Do you think there are any cocktails that you would eat with a meal, such as, dinner?
Well, the rules in there are kind of fuzzy. I mean, it's like one of the rules with wine. It used to be, red wine with red meat and white wine with white meat, and that's just kind of a guideline. I mean, I'm quite often drinking a red wine with fish or something like that. Like there's a good Bordeaux goes really well with a really good salmon as long as it's got the right spices and stuff on it. It's actually, pairing the two together. I don't, normally take and drink cocktails with my meal, but I will take and drink cocktails with appetizers and stuff like that. It's quite handy and actually rather inexpensive to go to a bar and eat off their appetizer menu and have cocktails or beer or something like that at the same time.
It's often the best stuff.
Yeah, and plus you can actually get a better experience from the restaurant itself because you can kind of see what the frame of mind is. And if you're sitting at the bar, you can have a good entertainment with the bartender itself. When I go to a restaurant, if I'm by myself or something like that, sitting at a restaurant table by yourself is not quite as exciting as sitting around with people. And so having interaction with the bartenders, to me, is kind of a fun experience.
The bar scene's definitely more social.
Yeah.
Now, isn't there a test strength that you gauge the quality of a bar? Is it the Manhattan, I think?
If I'm going to a bar for the first time, and I've never really dealt with a bartender before in order to find out whether he really knows what he's doing, I've got 3 drinks that I'll have him order. The first I do is an old-fashioned.
Old-fashioned.
And that's because I've learned that very few bartenders really know how to do an old-fashioned properly. And so it's how badly he makes an old-fashioned is kind of helps you understand whether he really knows what's going on. And then the second drink I order is I ask him for his personal specialty. Not the specialty of the house, not what the drink is popular, but his personal specialty. And depending on his reaction to there, I can kind of tell whether, he's interested in it. If his eyes kind of sparkles, oh, I've got a really good drink, then I know that I've got someone exciting there. If he says, well, gee, I normally just drink beer, it's like, okay, so here's a bartender that doesn't actually drink the stuff, imbibe in the stuff he's actually creating. It's like, going to some restaurant that, is known for their steaks, and you ask the guy how to make the best steak, and he says, oh, I don't know, I'm a vegetarian.
Right.
I mean, there's nothing wrong with being a vegetarian, but a vegetarian and meat, you almost kind of don't trust that he actually understands what he's doing quite so well. And then the third drink I order is I take and I order a drink of my own. Not one I've created, but one that I know that the bartender doesn't know. And this is kind of my way of see what his reaction is when he comes across it. Someone that maybe knows something about what he's talking about, and is he put off by that? Is he excited by that? Does that kind of create a whole conversation when you go on, and that can help you understand what's happening.
What's an example of a drink that you might say to a bartender you think he doesn't know?
Well, one I do is the aviation. Primarily because chances are he doesn't understand it, and second chance is he doesn't have the ingredients to make it with. And aviation is kind of like a daiquiri, but it's made with gin, maraschino liqueur, and lemon juice. And maraschino liqueur is something that a couple of years ago you couldn't even find in the United States at all. We're now seeing it more often than not. But other drinks I would ask for things like a tailspin, a floridita. If I'm in a place that maybe might be a little teeny on the upscale side, I might ask for a capriana. Or a mojito nowadays is more common than a drink. I used to ask for mojito quite a bit, but nowadays everyone's doing mojitos.
Capriana.
Yeah.
So many of our viewers out there probably don't know that in a certain world you are known by a different alias. What is that? Oh, well, it matches my cocktail stuff. I've got a website that I run that I called drinkboy.com. So you're Drink Boy.
I'm Drink Boy. It was a nickname that was given to me by some friends of mine who were at a nearby restaurant, and suddenly they started calling me Drink Boy, and the name kind of stuck, and I created a website based on that. And because of that, I've gotten a fairly broad range of a worldwide audience that I'm getting email from all the time and responding to questions from them, as well as communicating with other people that share my interest in cocktails. It's almost amazing that while I'm finding a lot of people that really have an interest in cocktails out there, it's almost surprising how many people don't have an interest in cocktails. How many people, like saying about wine. I mean, people are just going to wine up one side and down the other, and you go into a room and everyone might talk about their favorite vintage of this Cabernet or something like that, or know some detail about this winery. Where you go into a room and, you ask them about a martini, and they don't understand what a martini is. They think, any drink served in a martini glass or a cocktail glass is a martini. When that's not the case. The martini is gin, dry vermouth, and maybe orange bitters if you're lucky. Where a vodka martini is, you're saying, I want a martini, but please make it with vodka instead. But if you say something like a lemon drop martini, it makes no sense. I mean, lemon drop is a cocktail, but there is no such thing as lemon drop martini.
Because they usually serve them in martini glasses. Not that I would know from experience. But
it was more like, a cocktail. When you see these martini menus around, a martini menu, basically saying this is a cocktail menu. They're just using the term martini because it's the term everyone knows, but it's improperly used to call it classification of drink. Where martini is a drink, and cocktail is the classification that martinis are in. But that's all a little too geeky, I think.
So it sounds like you probably have a pretty extensive collection at home to mix and match with.
Yeah, I would say I've got a fair amount of bottles at home that I can do things with. I like to, when I'm traveling around and I see some bottle of some strange liqueur that I don't have myself, I take and order that. And if I hear of some drink that I don't know about, I go out and pick up the stuff for that.
So it looks like you have some stuff here to show us a new creation.
I thought I'd take and share with you a drink that I recently created myself. I don't normally get into creating drinks. I don't think that's really the whole purpose. It's more of understanding the cuisine of it. But this is a drink I created to use a couple of ingredients that aren't quite too common. It uses brandy and sweet vermouth, but also uses a drink from Italy called limoncello, which I know you're familiar with, which you don't always find around, and very few cocktails actually use it. And another ingredient here, which is peach bitters.
Peach bitters, wow.
Now, most people know about bitters. They know about Angostura bitters, which is the bitters you always use for most cocktails, stuff like that. Well, time used to be that there were dozens of different types of bitters that people use for cocktails. As a matter of fact, it wasn't a cocktail unless it included some type of bitters. Peach bitters,
like
orange
liqueurs
bitters.
They have
Well, like nowadays.
As far as the variety.
Yeah, same sort of the variety sort of stuff. And this is a bitters that there's only 12 cocktails basically that I've been able to find that actually use peach bitters. And recently, Fee Brothers was thinking about reintroducing peach bitters to the market and wanted to find some new recipes. So I made up a few recipes that use peach bitters, and I thought I'd try one of them here. And this is the Renaissance.
The Renaissance, great. Everyone should note that Robert keeps his drink recipes on his pocket PC. Can never be without it.
Take a look at the recipe there.
2 ounces brandy, 1 1/3 ounce sweet vermouth, 1/3 ounce limoncello, and 2 dashes peach bitters. Stir with ice, strain into a cocktail glass, and garnish with a lemon twist. Sounds great.
Unfortunately, I don't have any fresh lemons with me, so we won't be using the lemon twist, but as a garnish, we can kind of pretend that it's got lemon twist in it.
So what are some other drinks that you've made up?
Well, the Black Feather is one that I'm quite proud of. It's a drink that I created recently to use some of the same style drinks, using brandy and dry vermouth and Cointreau rather than limoncello, and a dash of bitters. I've actually got a personal bitters recipe that I created that I use for that. And Trident, Guadalajara, a few others. But like I said, creating cocktails is not what it's all about. It's all about understanding the quality of ingredients and understanding the recipes best. I mean, a lot of recipe books out there, they might have a recipe for something like a sidecar, but they're going to list the wrong recipe for it. I mean, a sidecar should not be equal parts of the ingredients. You actually want to take and carefully balance them. It's a balancing act you're working with.
So if you had to give up one thing, making and drinking cocktails versus writing code, what would it be?
Oh, that's tough. Suppose I wouldn't give up either one of them.
Oh, okay. Good answer. Don't want to compromise any positions here. Got the nice glasses.
Now you notice that the glass pours out crystal clear. And I notice that I also stirred it. That's another issue. If I would have shaken the drink rather than stirring it, it would have been all cloudy. And so
the whole shaken not stirred thing is actually useful.
It's incorrect. Yeah, you want to stir like a martini, like a James Bond martini. You want to stir it so it turns out crystal clear like this. If your cocktail has opaque ingredients like a lemon juice or orange juice or something like that, then you can shake it, because shaking really chills it down faster.
Well, cheers.
Cheers.
Nice, fruity.
You take the peach there a little bit on there, and lemons.
Lemon.
Yeah.
That's good. I like it.
I'm glad you're here.
Well, Robert, this has been fun. Thanks for talking with me.
I'm glad to be here. And that brings us to the end of another episode of The .NET Show. The 25th episode of The .NET Show, I might add.
That's right. Big celebration. Be sure to tune in next time, where we'll delve deep into the object model of the .NET framework.
And until then, we'll see you on the web.